Okay. So, quick reminder. 7.2 worksheet 1 is due today.
Why is it number 1?
Because sometimes I have a second worksheet or I have an alternative worksheet. It makes me know which one it is. Because we don't teach that concept.
No, I wish.
Okay. So, just a reminder. Your postulate sheet. I am not filling that in for you as you go. At this point, I will just let you know. You should have these top two filled in. You should be able to have this one filled in. And then on the next page, these 4 on the top filled in. Because we've talked about parallelogram properties. We have talked about properties of polygons in general, and we've talked about the first definition of a quadrilateral. We are going to be adding to some of those today, so we should have some more of those filled in. That's just kind of where we start. So, today open up your notes to section 7.4, page 9. Is that what it is?
Oh. I'm not that slow. Do I have a team? Yeah, just a lane. Is this like Is this a question?
Okay, so today we're diving into 7.4, which we're focusing in on specific types of parallelograms. Now, if a shape is a parallelogram, even if it's one of these specific shapes or specific types of parallelograms, it will still hold all of these properties. It will still have opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals will still bisect one another. Those things hold true for every parallelogram, even if we start talking about these specific ones, such as a parallelogram with 4 congruent sides. These shapes you technically should have learned of before. Parallelogram with 4 congruent sides is a rhombus. Parallelogram ABDC is a parallelogram, is a rhombus if AB is congruent to BD is congruent to CD is congruent to AC. All 4 of these are congruent. That's what makes it a rhombus, is all 4 of those sides are congruent. I should have probably written a little bit more above that, but we're just going to go with ABDC as a rhombus. On your postulate sheet, it starts off with telling you it is a rhombus if and only if. That way you can just write out the congruencies. Okay. Today we're also going to be talking about a parallelogram that has 4 right angles. Not a square, rectangle. JKML is a rectangle if and only if angle J, angle K, angle L, and angle M are right angles. Last one we're talking about today is if you have a parallelogram that is both a rhombus and a rectangle. In other words, it has 4 congruent sides and 4 right angles. Y'all know this one. All the sides are the same and all the angles are right angles. That one's the square. Now, in all technicality, by the definition, we can say it is a square if and only if it is a rhombus and a rectangle. Visually speaking, though, that means that, and that are congruent, and all of these are at right angles. That's what makes it a square. Y'all have heard of a rhombus, a rectangle, and a square before, right? By the way, what is the plural of rhombus?
Rhombi.
Yes, rhombi. Okay, so one of the things we're going to start doing in this chapter is identifying the quadrilaterals by their most specific name. It's called classifying the quadrilateral. You saw this question show up on your quiz yesterday, and then I realized, wait a second, we haven't done that yet. So, classifying them literally just means give me their most specific name. And so far, we've come across parallelogram, rectangle, square, rhombus, or just a straight up quadrilateral. To figure out which one's which, you got to look at what the properties are. For example, this first one. What do you notice about it? But are all 4 of the sides congruent to each other? It's got 2 pairs of congruent sides. 2 pairs of congruent sides, like this, means at very minimum it's a parallelogram. But what else does it have? 4 right angles. 4 right angles makes it a rectangle. Question 2, the only thing I notice about it is it has 4 congruent sides. If it's only got 4 congruent sides, we don't know anything about the angles, that makes it a rhombus. Because I have a cold heart.
There you go. Okay.
Question 3. I noticed 4 right angles and I noticed some congruent sides. 4 right angles means it's at minimum a rectangle. If it's a rectangle, it could also be a square if we know more. Is it a square? No. It stopped at rectangle. Square means all 4 of the sides are the exact same length as one another. This one's only got 2 pairs that are the same.
And so why we call that one, that looks like a square rectangle?
This one, same thing. Those are congruent, those are congruent. There's nothing that tells us that these are the same. Even if it looks like a square, unless we're given the information that guarantees it's a square, we can't call it a square. Okay, question 4. Rhombus implies all 4 sides are congruent. Do you have anything indicating those are congruent? Nope. The only thing I know is opposite sides are parallel. In a quadrilateral in which opposite sides are parallel, it is a parallelogram. Question 5. It is a square because it's got 4 congruent sides and 4 right angles. And the last one. I don't notice any congruent sides. I don't notice any right angles. I don't notice any parallels.
Why
quadrilateral. On your postulate sheet, I want you to take a look at the very back of it real quick.
Could you scroll up to the top real quick? I see it. Okay.
On the very back of your postulate sheet, you're going to notice this flow chart talks about different quadrilaterals. If something is a quadrilateral, it can be broken down as a possibility of being a parallelogram or a trapezoid or a kite. And on the pictures, you can kind of see the tiny little arrows telling you parallelograms have opposite sides parallel. If it is a parallelogram, it could be a rectangle or it could be a rhombus. And it shows you what is required to be either a rectangle or a rhombus. And then the last thing is if it's both of those, it's a square. We've so far gotten to this piece. We'll talk about trapezoids and kites later. But that flow chart is designed to help you kind of see what's what. Today, when it comes to our special parallelograms, we're going to be focusing mostly on rectangles though. So, today we've got the rectangle diagonals theorem. It states a parallelogram is a rectangle if and only if its diagonals are congruent. Diagonals are those. This is a rectangle if and only if AC is congruent to BD. Have we talked about diagonals with parallelograms before? Earlier in the chapter, we talked about parallelograms and their diagonals, and we talked about a property of them. In a parallelogram, the diagonals bisect one another. These pieces were congruent and these pieces were congruent, but nothing stated that the full diagonals were. If the full diagonals are congruent, that specifically makes it the rectangle. That makes it this. Now, it is still true that all of those old parallelogram things hold on a rectangle because a rectangle is still a parallelogram, which means it still has opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive interior angles are supplementary, and the diagonals bisect one another. That's still true. This is just an additional thing we know about rectangles. So, you're going to see problems like the following. Given rectangle QRST such that QS equals 5x minus 31 and RT equals 2x plus 11, find the diagonals of QRST. Notice how I gave you a picture of a rectangle here, but I didn't label anything on it? We got to label it ourselves. If it is QRST, start with one of the corners as Q. I don't care which one. I'm going to put that one. And then go around the shape to get the other letters in order. I don't care if you go clockwise or counterclockwise. But if I start here and I want to go around clockwise, then this one has to be which letter? R, S, or T? Has to be R. Going down below it, that has to be S. Going here, it has to be T. We were told that QS equals 5x minus 31. Where is QS on my picture? Connects from Q to S. It goes through the middle. What's this thing called? Nope. If it goes from one corner to a corner not right next to it, it's a diagonal. QS is a diagonal. The other one I was given was RT. What's RT on this shape? Also a diagonal. It's the other diagonal.
The lines have to be perfect.
No. You just have to know where they are. I'm drawing them in just so I know, oh, hey, it's talking about this. Oh, hey, it's talking about this. If you didn't even draw them in there, I wouldn't hold it against you. Okay. In a rectangle, the diagonals are congruent. What does congruent mean, essentially? Equals. So I can write an equation. What's it going to look like? Yep. And I set them equal and I solve. Haley, if I want to solve this, where am I going to start? Adding the negative 31? Okay. 5x equals 2x plus 42. Jada, how would you have me follow that up? Subtract. Technically it's 5x by a 2x when you're doing this, but 3x is equal to 42. Now what? Divide by 3. X is 14. Is that what the question asked for? What did the question ask for? Find the diagonals. In other words, find the length of the diagonals. What do I do? Plug it back in. Doesn't matter which one I plug into. First one, second one, or do I have to plug into both? I don't actually have to plug into both because we know they're going to be the same. Plug into one, and I got both of them. 5 times 14 minus 31, I'm going to go that direction. 70 minus 31 is 39. QS equals 39. RT equals 39. Okay. Quadrilateral JKLM is a rectangle. Okay. I like to put J, the first letter here, and then I go around. KLM. The measure of angle KJL.
I'm scared.
You're fine. When you do a 3-letter name, the middle letter tells you the pointy part of the angle. The outside letters tell you where to go with that angle. J goes towards K, but it also needs to go towards L, which means I have another diagonal that needs to go in here. Two x plus 4 is right there. It's an angle, which means it technically should have degrees on it. I don't know why it doesn't. I made a mistake. It's okay if you don't put the degree on it anyway. The other one is angle JLK. L is the pointy part, because that's the middle letter. Goes towards J, goes towards K. It's this one right here. It's that angle. I want to find X. Those are angles. Is this about angles? No, which means that's not helpful. But a rectangle is a parallelogram, which means I've still got these 4 properties. That's not angles. The bottom one's not angles. These ones. But these ones require full angles of the shape. Full corners of the parallelogram. Are either of these full corners? No. So I got to find something else to use to my benefit. It is a rectangle, which means what do you know? All four angles are 90 degrees. So would you agree that this is a 90-degree angle? This is a 90-degree angle. Technically, the big one's a 90-degree angle here, and the big one's a 90-degree angle here. Now, unfortunately, I don't know both sides of this in order to make adding up to 90 helpful. Same problem here. Is there something else, Zion?
How do we get the 90-degree angles in?
Because it's a rectangle. And by definition, a rectangle has four 90-degree angles. While we do have full angles in the shape, all that's going to tell me is both of these are 90 and both of these are 90. We already knew that. Is there something else that you see that might help us out? Maybe another shape showing up in the picture. Do you see that there's a triangle there? When I drew in one diagonal, I ended up with this triangle. Do you notice that we know something about each of the three angles in that triangle? What do the three angles of a triangle add up to? 180. So we're going to use the triangle. You don't have to use the triangle out every time. I'm writing it for the sake of our notes so we can see where we got things from. Three angles of a triangle add up to 180. 2x plus 4 plus 7x plus 5. One of the most common mistakes I see people do is then they write equals 180. What did I screw up? I forgot the 90. Three angles in a triangle add up to 180. Don't forget to add the 90. Lauren, if I want to solve this, where would you tell me to start? Simplify it down. 2x and 7x is 9x. 5 and 4 and 9 is 99. Yes, Jackson, we're going to subtract the 99. 9x equals 81. Divide by 9. X equals 9. Is that what we were asked to solve for? Yes. Okay, next one says, if JL equals 3y minus 5 and MK equals 5y plus 1. Okay, here's the thing. Do you notice that this is like a part B of a question? Which means it's still triangle JKLM. Gonna have to look at your instructions sometimes. This isn't the problem I wanted. It works. JL is one of the things I was given. It's not marked on there, but it is a diagonal. MK is the other one. It's not marked on there, but it is a diagonal. It's not an angle at all. What do you know about the diagonals of a rectangle? They're congruent, according to above. So I set them equal. 3y minus 5 equals 5y plus 1. Brody, if I want to solve, where would you tell me to start?
Subtract 3y.
Negative 5 equals 2y plus 1. Make sure we're leaving that negative with. Mariano, where should I go next? Subtract 1. Negative 6 equals 2y. Uh-oh. This problem's got an issue with it. Kylie, how would I finish? Yep, divide by 2. Y equals negative 3. You can have negative variables provided it doesn't make the side length negative. This one's actually got a mistake. It makes the side length negative. But that's my bad. That's not you guys. That's something I gotta fix. And that is what it wanted us to solve for. Okay, we've got one final problem. HIJK is a rectangle. Whose diagonals intersect at point E. Okay, gotta put my diagonals in. There's point E. HE is 12. IE is x plus 7. Find x. Are HE and IE diagonals? Are they full diagonals? Is that an easier question? No. These are parts of diagonals. Does the theorem on the top of the page tell us anything about the parts of the diagonals? No, it only talks about the full diagonals, which means we need to flip back and talk about things with parallelograms. Because a rectangle is still a parallelogram. And we do have a parallelogram theorem that talks about parts of a diagonal of a parallelogram. This one way down here. It says the parts of the same diagonal are congruent to one another. That's congruent to that, that's congruent to that. Knowing that, I can add that to information to my sheet. This is congruent to this is congruent to this. Do you notice that the two things I have marked have different tick marks on them? One's a single tick mark, one's a double tick mark. That'd be a problem. Except, here's the thing. This is a rectangle. Being a rectangle means my diagonals are congruent. Okay? So what that means is the length of this full HJ. If that's 12 and that's 12, the full length is what? 24, because 12 plus 12 is 24. Which means the full length of this one is also 24. And if these two are congruent, that means each of them is also 12. In a rectangle, because diagonals are congruent and bisected. Let's try bisected, not bisectal. All diagonal parts are congruent. Which means even though in my picture I had the different congruent marks, technically all 4 of those should have the same congruent marks. And I'm going to do double just because it's easier to change a single into a double than a double into a single. This is just putting two theorems together. So all four of those parts are congruent, which means if I want to solve for x, what does congruent mean? Equal. So if these things are congruent, I can write the equation 12 equals x plus 7 and solve from there. X is 5. So sometimes you might have to put a couple of different theorems together. Sometimes, much like we did with parallelograms, because a rectangle is a parallelogram, you might just have to use the fact that the sides are parallel. Okay, that is it for notes today. That was section 7.4, day 1, part 1. Today is Tuesday the 19th. Our homework's going to be due on Thursday. Thursday is the 21st. And it's a worksheet for y'all. I know, you can't see what I'm writing. I froze it because some people were still writing. But it's 7.4 worksheet 1. In fact, I told you guys last week, how many book assignments do we have left? None. That was the last book assignment for the trimester.